All right, so we're gonna talk about how to implement, right, a graph, right? So last time we learned the basic overview of graphs. Like for example, this is a graph where we have the connection between the cities and the edges with the wage. Like this could be the price of the tickets or the distance, right? So that's the wage. Like it's gonna cost 200 to travel from Austin to Dallas. Now, how are we going to write this code, right? So we said we can use an array base here. So an array base pretty much just showing you the array, one dimension array of the cities. Right, so when you do number of vertices, now vertices pretty much is 7. Right, those are the node of each city we call vertices or vertex. And we also have edges. Edges, that mean the connection that we talk about neighbors, like Atlanta. If you go back to image, Atlanta has Washington as the neighbor, and also have. So we pretty much just constructing a list of cities here, right? And we see Atlanta has 600, which is connecting to 6, which is Washington, right? Which vice versa, Washington has 600 connecting to Atlanta index 0, right? You see that. So Atlanta connect to Houston 800, which Houston connect to Atlanta. So we could construct two arrays, right? One is one dimension, and the second is two-dimensional arrays, right? So now when you declare pretty much how to implement it, we just start to declare an array of vertices as the T, because this is a generic. And the edges, for this part, we see a number, so we just use int, right, as a distance or wedges between the vertices. And we have a counter for like num vertices, and we set as max vertices too. And we start to have, we set no edges equal to 0 to represent an item with 0 right there, right? That there's no connections. So that's why we just do no edges instead of say 0. So pretty much it's null. And we have cap as 50. And when we do, we call traversals, right, to visit all, right? Last time we talked about when we can do depth first search and breadth first search. When we visit, we start to mark. Then we know that we visit, we don't want to revisit, right? So that's why we create an array of marks here, right? So start to look at the constructor when we initialize, right, num vertices to 0, because it's still empty graph, and that's just a cap. We can have just the max. Like this one is an array set to 50 nodes, right? So only 50 cities, which we don't have to set as max. We can increase that. But this is for the simplification. Now, we also want to create the vertices, right? New object. And we don't know the type, so we just do T, right? An array of vertices, and we need to do that. And then marks pretty much is Boolean, right? An array of Booleans. So, and edges two-dimensional arrays, right? With the default caps. So we need a default caps, right, to tell. And then this is a constructor that give you any size. Like I said, instead of limit to 50, we can do any size here, which has a limit form the user created, right? So when we add the vertex, so we could pass in, that's the method, right? Add vertex, the node to add. and then just iterate through it, right? And when we iterate through that, so first we said, okay, an array at that index, we get that vertex, right? Index 0, then we have something there. And then we start to iterate to see index equals to 0. This is for edges, right? So pretty much just first we initialize all the null edges. So just put them all to 0. And then increment the number of vertices. This is just show the UML diagram here, that you can have an interface and you implement that interface, right? So this is just trying to show what are the methods that we want to see, right? So we have is full, right? To see if it's full, is it empty? This is an array, so that's full. And at vertex, we just look at the method has vertex. Just iterate to see if it has another vertex, right? And add edge. So once we have like that, add vertex doesn't do edges. So that's why add edge is going to take care of assigning the weight into that two-dimensional arrays. So by providing form and to, right? So when you start to see form and to, then we add a weight. And we can do wedge is to check from here to there. What's the wedge for that? Get to vertices, right? So this pretty much just we want to see if I want to go to that vertex. So it's going to return a queue like the list of the right vertices that we have to walk through. Right, clear marks. Like when we visit, like I said, we mark that we visit. We don't want to revisit again. When we want to walk through, we start to mark. So we have mark vertex, right? That after we visit each node. For clear mark, it's just reset the whole thing. That means you start over again to do traversal, right? Is mark to check if it's a remark. Get mark, just get the T back. And this pretty much just you implementing it. Now let's look at if we want to use linked list best, right? An array. Instead of using, we know array for the city list, right? But instead of using two-dimensional arrays for the edges, we can use the linked list that pointing to the neighbor. Right, so like for example, Atlanta connecting to Houston, so we just have an index of. So now you may see that this node pretty much has what index of adjacent vertex, weight, and reference to the next edge. Right, so if we want to use linked list, we have to create a node, right, for vertex that has weight and reference to the next edge and the index of adjacent vertex. Like in this case, we say Atlanta is going to have the neighbor, which is Houston, and weight is 800. And this is pretty much just linked to, okay, Atlanta also have another adjacent, which is Washington. Wage is 600, right? As well as Austin's has Dallas, right, was 200, and Austin also have another adjacent, which is Houston, which 160. Which, if you look at this, we can do all linked list too. So we understand this blue part is the neighbors, right? And this is a list of all the cities. So we can have the vertices. This is the edge nodes. We talk about edge node that have weight and reference to vertex node, right? and reference to next age node. Now, since we don't use array, so that's why we don't have array number here anymore in index, right? We just have to have the reference to that adjacent node, which now is referred to Houston here, right? And that's referred to Washington. Right, this is the node itself, which is top of vertices node here, right? Right, reference to vertex node. So we're gonna have to create a vertex node, right? That has first vertex info, like the city name, and pointed to the next vertex node, and pointed to the first edge node, right? So that's pointing to the neighbors. So 2 pointers, right? List of all the cities, just like your linked list, but we have to have list to all the neighbors, right? To the edges, pretty much edge nodes. So we have to create a class that have 3 attributes, right? Like vertex. Class vertex has t, right? Info and vertex pointer and age pointer, and we have to create a class named age that has vertex pointer wage, which is an int if we want to use an int, which we can actually pass to the t type too if we want to, right? But in this example it's just an int, so wage int, and then age pointer, right?